Okay, hi everybody. I'm coming to you from my Windows laptop right now, so I want to show you that R looks very similar on Windows as it does on Linux. I'll mostly be working from my Linux laptop, but um, just to show you sort of what R does on Windows, it looks exactly the same. So once you've installed it, should have no problems working in Windows, with one exception, and that is if you are going to go outside of RStudio. So if you're not going to use RStudio, and let's say I wanted to open up here's my hello.r file that I was showing you before. Now, if I were to open that up in my text editor, my Komodo IDE, let's give it a second here. So here it opens up. I don't have any, real annotation on that. Remember, to get that, I have to sort of pick a language here. R is you have to go all the way down to the other languages here where there's lots of them. And I guess they just don't consider R to be very modern in Komodo, which is strange because it really is used quite heavily in data science. But there's R. With some annotation. It's not going to have self-correction like some of the other languages, but that's okay. That's what RStudio was invented for. So, but if I were to try to run this from the command prompt, the way I did with when I demonstrated the same thing on the Linux terminal, you would go down here, and if you've never done this before in a Windows machine, the program is called CMD for your command prompt, and that'll open up a window that you may never have seen before. And I'm not sure why my Xbox game is opening up there, but so here I'm at a command prompt. Now, if I were to try to open R the same way I did with in the Linux terminal, so that would just be a command R. All of a sudden I get, this isn't really recognized as an internal command. I can go to my desktop where I have my script and try to run it there. And again, the command for that was rscript hello.r, and the same problem. So what this is telling me is that the computer really can't figure out my file structure. So Windows, one of the main differences between Windows and Linux is Linux has a very explicit, very simple file structure and very uniform file conventions. Windows has a lot of sort of, because it's proprietary, it has a lot of folders and file structures that you as the user are not allowed into. I don't know where my R is sitting on my Linux. Or on my Windows laptop. I used to be able to run scripts about 6-7 years ago by doing this fairly easily, and I haven't been able to more recently, and I'm suspecting it's because R is just installing somewhere else in the Windows version, and without really knowing where that is, it's hard for me to go in and put the path to it. And if it was, deep within my Windows system, I may not even be able to get access to those files. So this is, always a problem. This is where an open source community like Linux has the benefit, because problems like this aren't allowed to arise. People will go in and fix them, Windows has no real incentive for making it easy for you to run an R script off of their command prompt. That would be something that would be relatively low on the order of business for most Windows users to want to do. So they're not going to do that. But Linux is really, developed for the programming community, where people want to be able to use the terminal and use it with all of its power and flexibility. So that sort of thing wouldn't be tolerated there. So I would just at this point avoid trying to write programs sort of like this that you're going to be running off of command prompts, unless you're really doing it for the Windows user and if you're doing some sort of development project that's aimed eventually at Windows users, then you may need to come here, but we won't worry about it for the sake of this class at this point. But we go back to RStudio. I want to show you sort of one thing one last thing about getting started with R, and that is importing data. So the example I showed you before, I actually had written the data right into my script. You really wouldn't be doing that typically unless you're just trying to play around and figure out how things run. You'd be bringing in a much larger data set. It might be something that actually originated first from Excel. So here's an example of an Excel spreadsheet that I created with some data points in it representing time and temperature. Now, once you've done this in Excel, there's many ways to do this, with R. But the first thing I would do is you can actually write R scripts that'll work right with Excel. I tend to not to want to do that because again, Excel is a proprietary Windows product, and if they make changes or things to it that are out of my control, then I can't really, it could negate a lot of years of my own coding or something if I had a lot of things that depended on Excel. So I would, even if I'm working in Excel with data, I would, just to be safe, I would go in and I would save a data file and handle it as something a little more primitive. So if I go in and were to resave this, you can of course save things as Excel workbooks, but there's lots of other formats here, and the text formats are probably the best. I prefer to do kind of things with tab delimited text files. So I've already saved this as a tab delimited text file, and if I were to open that here and sort of show it to you in a very simple editor, it's going to look like this. So the separations between numbers are actually tabs, or you'll use your tab key. You're not going to use white space. Don't use the space bar. That'll sort of mess things up. Always use a tab when you're delimiting columns in this sort of format, or do it in Excel and then just save it as a tab delimited file. And then call it. So it'll have the suffix, instead of XLS, it'll have the suffix TXT. So how would I get that up in, in Windows? So I can write, so I went ahead and I'm using a function called read.table. There's also, if it was comma delimited, I could use read.csv, and it should work the same way. There's two arguments to this function that are necessary, and there's a lot more arguments, that are available. So to go to read table, look it up on the R documentation site, you can see that there's a lot of arguments that you can possibly put into it. It's really a complex function if you want to learn how to use it, but it's also very simple to use as well. And then there's examples here at the bottom. And this is a primary way that I use data input into R. Again, I use R often as a backend just to do statistics and make some plots. So my data is always coming from somewhere else, usually some other program that we've written in Python. So we want to bring the data over here into R and take advantage of the R libraries and packages that are saving us time. So again, I would sort of create a data field or a data object here using the read table function, and then I can, let me make this a little bigger so it's maybe easier to see. There. So you can see I've got a full URL here that's pointing to where my file is. Sometimes you can get away with just putting my data.txt in here as the reference to the file. But I wouldn't do that because as soon as you send it to me or it goes to another computer, this script may no longer work. So always use sort of a full path. Or if you're pointing to something online, a full URL should always go here. And then there's a logic statement here about headers. Are there headers in my table? And in this case, they are true. So logical statements are always in all caps. So true or false. In this case, it's true. And if we were to take a quick look there, you would see that that I have headers for time and temperature on the first row, and I want to ignore those. I don't want my computer to think those are numbers, basically. So by putting header equals true, I can avoid that. So I can go back here and Now, the way I would usually work with this is once I've got those in, I'm going to have two columns, and I want to sort of set those up as essentially independent pieces of data. I could bring the whole thing in and sort of shape it as a data frame and probably get a plot out of it. But I like to do this. It's a little more explicit, and it allows me later on to sort of handle time and temperature in more independent and different ways. So if I have different columns and I may want to do different things with them in a more complex script, once I've sort of laid out each column in my table and given it a name in my script, it's a lot easier to do that. So there's a data, which is the name of my my table. I might have wanted to call that something a little more self-referencing. An important thing about code, I'm going to talk about this in another video on best practices, is to make your code as self-referential as possible. So I use things such as, instead of just calling this plot, I call it my plot, sort of designated as something that I've created or owned. But I might want to give it more details. It could be specific to a particular analysis or a particular date that I did the analysis, things like that. And I like to see those things, even though they make variable names relatively long. I think they're good. I think it helps you understand what you've written in the future if you were to go back and look at it. And that's always important. This little $ here is actually pointing and looking for the header that's called time. So this has to match the header in my table, this part of this statement. And then this has to match the name of whatever I've given that table in my script. Now, I can call it whatever I want to here, and I might want to just use the header that I had in my table, but I don't have to. In the case of my table, you notice my header was rather long. It was the word temperature, and I might just want to call it temp here. So I can change that. So I just did that to make that a little more clear. Now, if I go ahead and run this, it should give me plots very similar. And I'm using a line plot here instead of a points plot. You can see, so I'm using geom line in my more complicated plot, and that one's coming up afterwards, so it's overlapping over my simpler plot. But again, I'm using time and temp as my two variables and plotting them here. So relatively simple. Can close this and make sure that the other one popped up as well. Now you can see here I have a lot less control about maybe creating a line. I would have to add more lines to my script below this plotting function here, like I said before, and I'd have to sort of designate that I would add a line and maybe colors for the lines, and if I wanted grids or wanted to change things in the thing, I would have to just add more to this code, which would be tedious. And this is the advantage of the ggplot, is it just simply by changing it here, it's really given me quite a different output without a lot of effort. So my advice to you is always use ggplot. Learn how to use it, and don't use anything else with R. So that's that. Let's go ahead and talk a little bit, and I'll close this whole video with kind of a run through of some other packages that are very useful to have. Another one that I like to use a lot, and this is explained here, if you were to search grid extra as one word with a capital E. So this is the grid extra library or package. So this would be install.packages grid extra, and then you can use it with ggplot. And one of the things that it lets you do, which is pretty cool, is it lets you put multiple plots on a single PDF page. So if I had 4 or 5 different statistical analyses, I could put those up here, and I could have different outputs for those, and even do lattice plots. I can arrange them different sizes. There's lots of complexity, lots of ways of making your output look just exactly the way you want to here, which is nice. This is really nice if you're trying to publish papers and you can create the outputs, and use multi-panel outputs and create them very easily here. Another very useful basic function is called mice. This one is pretty powerful, and what it does, if you have a large data set and you have some missing data in those data points, it will go in and use a process called imputation, and it will actually impute missing values into your table. This is very, very important if you're going to be doing machine learning, because machine learning is very, very sensitive to missing data points. So, so this is a way of actually using multivariate statistics to go ahead and make predictions about data points that are missing in your data. And we all have missing data points. If you're out collecting data on birds, you might have missed a particular day. You might have missed a particular count for some reason. And that could be in your data set. A couple other packages. All of the machine learning packages are pretty are different, and things that you're going to be loading in. The very first one in R, though, was called the E1071 package, and it had a lot of different ways to do machine learning. So it's kind of a good place to sort of start. Another one that sort of has been around for quite a while is called KernLab. This is for kernel methods like support vector machine and things like that. So these are nice because they're always parameter tuned, so they always will sort of adapt themselves to your data before they actually try to do the learning. So they're quite sophisticated. These are just two examples of things you would again use: install.packages and KernLab to bring that one in. But there are literally thousands of packages out there in R, which is why we use it. It's very powerful. So that's pretty much it for this video. I'm going to come back later and probably teach you a little bit more about the ins and outs, the details of particular statistical functions and whether those are functions that are part of packages that need to be imported, or if they're part of the base R program and they're already there. I'll also say there's also data sets that are built into R. So there's famous data sets. The Fisher Iris data set is built in, and you can just call it, I think, with the word iris. So there's some data sets there's data already available if you're going to play around with it and start to learn. But at some point, you're always going to need to bring data in, and that's where this read table function is really critical.